A man is lying on a rooftop at the edge of the Sahara. There is no fan, no fridge, no ice, no shirt on his back, and somehow he is having the best sleep of his week. That's not a survival story. That's Tuesday. By the end of this video, you're going to understand why a civilization with zero electricity solved the problem we still haven't fully solved with all of ours. Here's the number to hold on to. 43 degrees Celsius, 110 Fahrenheit. That's not the record high in ancient Egypt. That's an average Tuesday in July. No air conditioning exists. No refrigeration exists. It won't be invented for another 3,000 years. And yet people didn't just survive that heat. They built one of the longest-running civilizations in human history inside it. Pyramids, temples, writing, government, medicine, all of it was engineered in conditions that would put most modern people in a hospital bed by lunchtime. So here's the question this video actually answers. Not, how hot was Egypt? Everyone knows it was hot. The real question is, how do you keep several million people alive, working, and sane for 3,000 straight years, with nothing but mud, cloth, and beer? Because that's the actual engineering marvel. Anyone can stack rocks into a triangle given enough time and enough rope. Keeping the workforce alive long enough to finish it. That's the hard part, and almost nobody talks about it. We picture the Egyptians grinding through the heat, suffering it out, toughing it through by sheer willpower. That picture is wrong. They weren't enduring the desert. They'd spent thousands of years quietly engineering their way around it, until the heat stopped being a threat, and became something closer to a variable they'd already solved for. Every part of daily life was fine-tuned across dozens of generations. The shape of the house, the fabric on their back, the hour they woke up, what they drank at breakfast, all of it was aimed at one target. And to understand how, we need to start with the least glamorous fact in all of Egyptology. Sweat. Your body has exactly one serious cooling system, and it runs on water. Push fluid to the skin, let it evaporate, and it drags heat off you as it goes. That's the entire mechanism. It's also a mechanism with a spending limit. A person doing hard labor outdoors in that climate can burn through several liters of water in a single day. And the moment you cross a certain threshold, your thinking gets foggy before you even notice something's wrong. That's the cruelty of heat stress. It takes your ability to detect the danger before it takes anything else. And there's a second trap almost nobody knows about. Sweat carries salt out with it. You can drink all the water on Earth and still collapse, because your nervous system needs the sodium you just dumped onto the ground. So the entire survival equation for ancient Egypt comes down to exactly three moving parts. Cut the heat coming in. Replace the water going out. Replace the salt going out. Everything else is just an increasingly clever version of those three moves. And Egypt solved every single one of them, without a single volt of electricity. Start with the house, because this is where it gets genuinely brilliant. Egyptian homes were built from mudbrick, Nile silt mixed with straw, baked hard in the same sun it was built to defeat. And mudbrick has a property modern buildings have spent decades trying to reinvent. Enormous thermal mass. A thick wall doesn't block heat. It delays it. Sun hits the wall at noon, and that heat takes hours to cool through the material. So it doesn't arrive inside the house until well after dark, right when the desert has cooled off, and the extra warmth is actually welcome. Meanwhile, last night's cold is making the same slow crawl in reverse, landing inside the house at the hottest point of the following afternoon, exactly when it's needed most. The wall isn't insulation. It's a time machine for temperature, and it takes the brutal daily swing of the desert and flips it completely out of phase with human need. Nobody wrote an equation for that. They just noticed thick walls made life better. Thin walls made it worse, and built accordingly for 3,000 years straight. Then they stacked more tricks on top. Small high windows, because heat rises, and you want the exit near the ceiling. Whitewashed walls, bouncing sunlight back off the surface instead of soaking it in. Narrow streets, so buildings shaded each other most of the day. And a flat roof that wasn't dead space. It was the best room in the house. On the worst nights, the whole family moved their bedding up there, where the air moved freely, and the ground stored heat radiated straight up into a clear sky. Sleeping on the roof wasn't hardship. It was the premium suite. Now here's the part that should genuinely surprise you. Some households didn't stop at passive tricks. They built an actual machine. It's called a malcaf, a hooded scoop mounted on the roof. It was angled to catch Egypt's reliable northern wind, then funnel it straight down a shaft into the room below. Meanwhile, the hot air already inside escaped through those small high windows on the other side. Wind in, heat out, zero moving parts. Powered entirely by two facts that will never stop being true. Wind exists, and heat rises. And then some households pushed it one step further. They placed a porous clay jar of water directly inside that airflow. Water seeps through the clay. It evaporates off the surface and pulls heat out of the air passing over it. By the time that breeze reaches the room, it's already been cooled. That is an evaporative cooler. That is, mechanically, the same appliance sitting in a hardware store today for $200, running on a wall outlet. They built it with a hole in a roof and a clay pot. The idea never actually died, either. It spread into Persia and evolved into the towering wind catchers still standing today in cities like Yazd, some of which still work. We didn't outgrow the technology. We just got cheap electricity and decided burning fuel was more convenient than thinking. Now the body instincts has stripped down in extreme heat. Egypt did the opposite, and the material science backs them up completely. Nearly everyone wore linen, spun from flax, and linen happens to sit almost perfectly on top of this exact problem. Its fibers are hollow, so air moves straight through the weave. It wicks sweat off the skin and spreads it out to evaporate efficiently. And it's a poor insulator, so it never traps the heat you're trying to lose. Loose linen over skin can actually keep you cooler than bare skin because it blocks direct solar radiation while still letting sweat evaporate underneath. You trade a little airflow for a lot of shade, and it's the same math that pushed desert cultures across North Africa toward flowing robes instead of shorts. Bare skin under a desert sun isn't freedom. It's just a faster sunburn. Then there's the water problem, and this is where it gets clever in a way that still catches people off guard. The Nile was right there, but the Nile was also full of parasites, silt, and waste. And a disease spread through freshwater snails has actually been found preserved in Egyptian mummies. So Egyptians drank beer instead, at a civilization-wide scale. And I need to be precise about what that beer actually was, because it wasn't a pint at a bar. It was thick, low in alcohol, closer to a gruel than a drink, and it delivered calories, B vitamins, and hydration all at once. Brewing involves heating the mash, and fermentation creates an environment hostile to a lot of pathogens, which meant the beer in a worker's jar was frequently safer to drink than the river outside his door. This wasn't a lifestyle choice. It was infrastructure. Records from the village of Deir el-Medina, home to the craftsmen who carved the royal tombs, list daily rations of bread and beer as standard wages. And when those rations arrived late under Ramesses III, the workers didn't shrug it off. They put down their tools in what stands as one of the earliest recorded labor strikes in human history, over food and beer. Once you understand what that ration actually was, the strike stops looking petty and starts looking exactly like what it was. Workers refusing to keep laboring in extreme heat once their cooling system got switched off. Salt handled itself almost by accident. Bread was gritty enough to visibly wear down teeth over a lifetime. Salted preserved fish was a diet staple, and dates and figs supplied potassium alongside all that beer. Nobody was thinking about electrolytes. Nobody needed to. Whatever combination worked got repeated for 3,000 years. Whatever didn't quietly disappeared. And the accumulated result looks almost exactly like something a modern sports scientist would design on purpose. And then the simplest solution of all, the one everyone forgets. Just don't be outside for the worst of it. The Egyptian workday was built around the sun, instead of fighting it. Heavy labor before dawn, and an early morning. The dangerous middle of the day was reserved for rest, shade, and sleep. Work resumed as the sun dropped. Even the pyramids ran on this logic at a massive scale. Construction labor was organized around the annual Nile flood. When farmland went underwater, agricultural workers became available, and moving stone by boat got dramatically easier. The workday, the year, and the biggest building projects in human history, all bent around one thing. The sun set the schedule, and everyone adjusted to it. Now here's the turn, because everything up to this point treats the desert as the enemy being managed. That's only half the story. Egyptians drew a hard line between two words. Kemet, the black land, the narrow fertile strip along the river that made life possible, and Deshret, the red land, the desert stretching out on either side of it, lethal and endless. And that red land was, functionally, a wall nobody had to build. Hundreds of kilometers of it flanked the Nile on both sides, and armies simply could not cross that terrain at scale, while civilizations elsewhere were being conquered and reconquered on what looks, historically, like a rotating schedule. Egypt held a continuous identity for 3,000 years, largely because of a natural barrier that never needed a single soldier to guard it. It goes further than defense. That same brutal dryness is the reason we know anything about Egypt at all. Organic material rots fast in humidity and survives almost forever in dry heat. Every scroll, every scrap of linen, every preserved body sitting in a museum exists because the same climate that made daily life so hard also made decay nearly impossible. Mummification itself grew directly out of that geology, an attempt to artificially reproduce what dried desert sand was already already doing to bodies for free. The heat didn't just get survived. It got put to work. It guarded the border. It preserved the archive. It's the reason a civilization from 3,000 years before the modern era is, in some ways, better documented than most of medieval Europe that came thousands of years after it. So picture the full system one more time. Now that you have every piece, walls thick enough to hold yesterday's cool air until tonight. A scoop on the roof pulling the north wind straight down into the room. Cooled on the way in by a jar of evaporating water. A family asleep under open sky. Because the roof is the best seat in the house. Linen worn not despite the heat, but because of it. A jar of thick beer waiting at sunrise. Doing more real work than it gets credit for. A workday bent completely around the sun. None of it needs a power source. None of it has an off switch. Because none of it ever needed an on switch. And none of it can break in a way that modern hands can't fix. We've spent the last 100 years solving the same problem a lot louder. Sealing off one room, running a compressor, and pumping the waste heat straight into the street. Which makes the street hotter. Which means the next building over needs an even bigger machine just to keep up. Meanwhile, there are architects right now studying wind catchers painted on 3,000-year-old tomb walls. Because it turns out a hooded vent aimed at the wind was a genuinely excellent idea the entire time. You'll get warm today too, and you'll do something about it almost without thinking. Step into shade. Reach for something cold. Sit near a fan. Wait out the worst of the afternoon. Same body, same sweat glands, same narrow margin before your thinking starts to slip. You're running the exact same calculation a laborer in Thebes ran 3,000 years ago, standing in the same heat. Except his house had already solved half the problem before he even woke up. So here's the actual question. If I took away every appliance you own right now and handed you nothing but mudbrick, linen, a rooftop, and a jar of warm beer, how many days do you honestly think you'd last before you broke? Put your real number in the comments. And if this one pulled you in, there's another one waiting right below.